Now let's look, how does wire EDM work? Wire EDM is like any other machining process. However, it uses a unique method of cutting metal that is electrically conductive. We start over here with a new wire electrode. There's a pulley over here and it comes through, and here's an upper diamond guide. Then the wire goes through this here flush port. Now they're usually closer together, but this is just a drawing. And notice there's an arrow over here, and let's go to the bottom over here. And otherwise, here we see pressurized, filtered, and cooled dielectric fluid. And I'm going to explain a little more about what that does. And there's a pump then that pumps this water, and notice over here it goes through the upper guide and also through the lower guide. And notice here there's a lower diamond guide over here. And this is the workpiece. So here's the wire going through here. And then the bottom roller, over here the wire goes out. This is the used wire electrode. As I demonstrated in the previous videos, this goes out here, and on the new machines it gets chopped up. Now let's go and actually look inside where the workpiece and the wire is and what happens. And that's in this drawing over here. This is the wire electrode, this black over here. The yellow is the workpiece. The magenta is deionized dielectric fluid, surrounds wire electrode and workpiece. Now this is important. When we get over here, we're going to explain what happens with the dielectric fluid over here. Now the voltage and the amperage control the spark between the wire electrode and the workpiece. So there's controlled sparking taking place over here. And here's the EDM power supply, the volts and the amps, that's going to create later on in this drawing a spark. Now let's see what happens when the sparking takes place. Here again is the wire electrode. This is the dielectric fluid. This is the workpiece. Dielectric fluid acts as a resistor until enough voltage is applied. Dielectric fluid is basically fluid that doesn't conduct electricity under normal circumstances. Now the fluid that we use in the EDM machines is water. Normal water has too much minerals in it. And so what we have in the machines are resin tanks to control the conductivity of the water. Remember, pure water does not conduct electricity. It's the minerals that they get from the ground that goes into the water and causes it to be too conductive. So these resin tanks then control the conductivity of the water. Between the electrode and the workpiece, there's this here water, this dielectric fluid that acts as a resistor. Now remember, this brass wire in this workpiece, there always has to be a gap. If this wire touches the workpiece, we have a short circuit. So the secret of this wire EDM machine is a servo mechanism that always maintains a gap between the workpiece and the wire electrode. So whether we're cutting straight or up to 45 degrees taper, there is always this gap that is present. Dielectric fluid acts as a resistor until enough voltage is applied. Then the fluid ionizes and sparks occur between the wire electrode and the workpiece. So here we see the sparks occurring between the wire and the workpiece. An interesting thing happens during the sparking process. There's only one spark at a time. Now this drawing over here, we see multiple sparks at the same time over here. But it's basically one spark at a time, but multitude, thousands of sparks per second. Then it says here, sparks precisely melt and vaporize the material. Now notice this word precisely. I just want to give you a little idea. I'll use this as an example. I have an item here that we cut out, it's a round circle. Let's make believe that this diameter is a human hair. The average thickness of a human hair is 2.5 thousandths. And I'll write this on the chalkboard. It's 0.0025. So if this diameter is a human hair, There are 25 1/10ths in this human hair. So we can cut then plus or minus 1/25th of a thickness of a human hair. Let us look at some examples of wire EDM cutting. The first example we have is this Texas Tech symbol that we're making for their football team. And what we have in the machine is this big T, and we're making that a cutout in there so the small T will fit into it. Now there we have the nozzles up in the air. This is not the ideal cutting condition. The ideal cutting condition for wire EDM is the top nozzle and the bottom nozzle to be on the workpiece. And the reason we do this is so they have maximum flushing pressure, because we have to get rid of the eroded particles. However, if we showed you this example, you wouldn't see any sparking. So what we have then is the nozzle up in the air, and the first example is with no flushing, and the second example is when we put on the flushing. The second example we have is this reliable EDM showpiece. And here you can see the wire electrode along the whole surface and sparking occurring. Now we're doing the first one with no water in the tank, just the water rolling along the surface. This again is not the ideal method. This is a machine that is totally submersible. The second cut, you'll see the ideal way to be skim cutting, where we have this filled with water, and there it is skim cutting. But you don't get as good picture in the second one as in the first one. So that's why we have shown you both ways of how we're doing our skim cutting. There are rapid electrical impulses between the wire electrode and the workpiece. Now let's examine what happens between the on and off times of this here sparking process. When the sparking process is complete, the melted workpiece material is cooled and pressurized dielectric fluid removes the eroded particles. A filter removes the EDM chips. Now you were creating chips over here. So now you have this, going back again to this drawing over here. Here we have pressurized dielectric fluid being pumped through these flush cups to, as you see over here, and the pressurized fluid removes the EDM chips. Here's another drawing of this here path of wire electrode generated by CNC automated computer system. Here's the pressurized fluid on the top and the bottom, which escapes, and the spark erosion causes the material to be eroded. The material removed is cooled by the dielectric fluid, and that's another feature of the dielectric fluid. It cools the material. Remember, if there's too much heat, everything expands and you lose accuracy. So there's a chiller on these machines to keep the temperature of the water at a certain temperature. This is extremely important for accuracy. The gauge of wire ranges from 0.001 thousandths to 0.014 thousandths. In millimeters, it's 0.025 to 0.357 millimeters. In our shop, we generally go down to 4 thousandths thick wire. But we need to remember, when you use these smaller wires, like 4 thousandths or 6 thousandths or 8 thousandths, you cannot put that much electrical current into it. So it's a slower cutting process, and it becomes more expensive. Another thing we need to remember, also, that the wire electrode never contacts the workpiece, that there's always a gap. Now, depending upon the energy of these sparks determines the surface finish of the EDM parts. Now, we can take a rough cut, and you will look and say, well, that looks very good. Now, we can make these sparks very minute, and that's what we call skim cuts. We go over and over again, and we can get practically a mirror finish that way by having these sparks very, very small, very little amount of energy. So these pits are not as large as these. They get smaller and smaller, And you can see that we get practically a mirror finish with wire EDM. I'd like to show you an example of the finish that we get with a rough cut. Now this is a 40-inch part that I'm pulling out over here. Now just take a look. I'm going to put a flashlight at the other end so you can take a look at it.
That's good. It's amazing because from this angle it looks really dull. It looks really, you're good at.
We have examined the wire EDM process, how it cuts, how it machines. And remember, wire EDM can cut any electrically conductive material. Even this tube bit has been machined with wire EDM. This is carbide, and it's been silver soldered onto this metal shank. It can cut also hastelloy, inconel, and other exotic materials. Extremely fine finishes of below 15 RMS can be produced with wire EDM. Even in the so-called rough cut that we demonstrated before, this part, we will get an excellent finish. This fine finish is present even when very large parts are cut. In other cutting operations, such as lasers and abrasive water jet, the larger the part, the rougher the finish. The reason for the smooth finish with wire EDM is that the wire electrode goes through the entire part and spark erosion takes place along the entire wire electrode. For instance, on this part, the wire electrode went through the entire part, not like in laser, which cuts with light, or abrasive water jet, where the abrasives come on the top and then it sort of mushrooms out. And also laser cuts with light and the light mushrooms out, but not with wire EDM. Wire EDM, the entire electrode goes through, and that's why it can cut so accurately.